you're able to detect anything going on there. Now this is an example of a DNS response that I injected some information into. This is actual, if any of you have heard of Rickrolling with Rick Astley's Never Gonna Give You Up. What I did is I actually put the entire lyrics of Rick Astley's Never Gonna Give You Up onto the end of this DNS response. And as you can see, looking at it with Wireshark here, it's saying we have a standard query response, no errors, one question, 5 answers, so on and whatnot, and it doesn't care less. And unless you actually look at the raw data of this, you're never actually going to see what's there. And now, while it sticks out like a sore thumb here, there's obviously going to be a lot of methods of making that much more covert. A, you're going to make it smaller, and B, use non-character values. Like if you look at the start of the packet there, you have a bunch of dots, things that can't be interpreted. It'd be very simple to use the method where you stick data in the middle of the packet, and they just come out to look like dots like that. Who honestly can look at a DNS packet, a raw DNS packet, and say what's going on there? So it's actually pretty effective. So the tool is called PSUDP, and it's a kind of a triple play on words on why I chose that name. First of all, it kind of stands for PSUDP, or PostScript, that which comes after the writing. What I'm doing is I'm sticking data, sort of an actual second UDP protocol on top of UDP. After the actual legitimate packet, which is where the pseudo UDP comes in. It's sort of a fake and alternative UDP on top of UDP. And then lastly, because of pseudo UDP, it's UDP, but a little extra power added to it. And of course, another obligatory, make me a sandwich. Some of you will have gotten that. Okay, so there are actually 5 executables in the PSUDP package. 3 of them are for what I'm calling this brokered architecture, and then 2 of them are for a point-to-point system. For the brokered architecture, this is sort of your network-wide covert communication thing I was talking about, where you're going to want some sort of broker at the DNS server that's going to have access to all of the systems and is legitimately going to see network, because once again, we're not actively creating packets, we're just looking at legitimate packets going through. So it needs to be on a system that sees as much traffic as possible from as many different systems. And what it's going to do is store and forward messages between clients. And then you have your clients, which inject DNS messages to the broker and listen for incoming messages from the broker. And both of these programs are going to be running all the time. They're constantly on. So what you have is a third executable, PSUDP, which is responsible for passing messages up to the client to send out, doing that through a Unix domain socket. So it's just a quick send this message, okay, and then it exits. And then the client will hold on to that, waiting for passive traffic to throw it onto. And then for the point-to-point system, which I demonstrate with the injector and listener here, is sort of a data exfiltration file transfer, is what I'm going to be demonstrating here. And for all these, they're all going to be manipulating the packets using something called LiveNet filter Q, which I'll talk about more in a little bit. But to kind of show diversity and how you don't actually have to manipulate the packet, I'll use LivePCAP for that. But I'll talk about that more in a little bit. So the basic flow of the brokered architecture on PSUDP, it's basically a messaging system. I didn't create anything that was actually out of the box, could be used malicious in any way. I'm not necessarily in that business. I'm primarily showing what can be done, and if someone wants to go and create something after that, so be it. But basically what the messages do is they piggyback on the legitimate traffic going through the system without ever creating legitimate packets. So if you look down at the bottom design, you have a client. So say the client just opened up their browser and sent out a couple DNS requests. What it's going to do is it's going to look and see if it has any messages it needs to send out to anybody, not necessarily the broker here. If it has a message to send out to anybody, it's going to append that onto the outgoing DNS packet that's going out to the broker. The broker is going to strip that off and send back just a typical DNS response back. Then it's actually going to hold on to that message there. It's not going to deliver it at that time. It's going to wait till the recipient of that message sends a DNS request later, which may or may not have a message on it. And then it's going to append the message that needs to go to that recipient onto the DNS response that's going back. So there's a lot of waiting going on. It's not going to happen immediately unless there's a lot of DNS traffic going through the system. As I mentioned, PSUDP uses LiveNet filter Q, which is a kernel packet filter that allows you to inspect and mangle packets through user space programs. It's usually used in combination with IP tables, where you say what traffic you're looking for. It's going to pass it up to the user space and let you manipulate it and play around with it at that point. It's actually a really cool setup, and it's something I'd recommend people try to play with a little more. I haven't seen a lot of really good uses with it yet, and I think it has the potential for it. And although it's not necessary, PSUDP will actually fix the packets before it finishes delivering them to the application layer. But this isn't necessary. It's good hygiene, I guess you could say, but it isn't necessary, and that's seen with the listener executable I showed that uses live pcap instead of netfilter where it just listens and doesn't modify the packet at all before it reaches its destination. Because it's important that all these packets still work as intended. None of these are going to cause a problem with any of the programs. Now, as far as message management goes, the clients basically just keep a linked list of messages that they still need to send out that have been passed up to them from the PSUDP executable. And anytime it sends a packet out, it's going to look, see if there are any messages to send out. If there are, it'll throw one onto the DNS packet and send it to the broker. The broker will detect these messages, and it keeps a hash table using the destination as a key. And each of the elements are a linked list of messages intended for that destination. So anytime it receives a message, it'll throw it into the appropriate linked list. And then anytime it's going to send a response out, it'll check this hash table for that destination. If there are any messages in that linked list, it'll throw it on there and send it out. Demo time. Now this demo I have been struggling with severely because at home I had an 8 gig system where I could have 3 virtual machines, each with 2 gigs apiece, and things were beautiful. Now I have 2 gigs in all. So I'm going to try and do this with just two virtual machines. So it won't be quite as fancy as a demo, but it'll still work. All right. Probably should have colored these differently, but here on the left we have the broker, on the right we have the client. The first thing I'm going to do is show exfiltrating a file, just point-to-point system. All right. Give me a second for some setup here. All right, so we're going to call the injector. And then also you can specify as a flag a certain domain you want to be injecting to. So say you have, like with DNS prefetching, you may have DNS queries going out to all sorts of different domains. You may want to focus on a specific one. So we're gonna say google.com. And then we're going to give it the file we want to send. In this case, we're going to send the Rick Astley lyrics. Okay, it's read the file in, it's ready to go, but it's waiting because there aren't any DNS responses going or queries going through the system right now. Now we're going to come over here, set up our listener, and he's listening for google.com. So now what we're going to do is we're going to go over to the other browser, or go to the other system here and just browse. Once again, it's looking for the google.com domain, so we're just going to visit that here. The second we hit that website and the DNS request started going through the system, over here we have the lyrics spit out. We're no strangers to love, you know the rules, and so do I, yada, yada, yada. Most of you probably are familiar with that song. All right, now what I'm going to do is actually do the brokered architecture. In this case, as I said, by the time I get the third virtual machine up, things crawl to a halt. So I'm actually going to cheat a little bit here and send it to my own system. I'm going to say send this message to myself. So it's going to jump to the broker, and then the broker is actually going to send it straight back to the client. All right, so we got the client going here. Now we're going to set up the broker. Should be good. All right. So both the broker and the client are ready. As I said, they're both running all the time. They're waiting for data. So now we're going to come over and run that third executable, the PSUDP program that passes messages up to the client through a Unix domain socket. Actually, I have no idea what the IP address is. All right, so we want to send this to 24.120.50. Okay, there we go. Okay, so it says we're sending hello Black Hat USA 2010 to this IP address. But right now it's still waiting at the on the client because there's no DNS traffic going through the system. So now we're going to open up our browser again. And here we go over at the broker. We received the message. Okay, so we got a message from 24.120.250.120 going to the same IP address. Hello, Black Hat USA 2010. So now back over here at our client, we see that it went ahead and received that message. Now, in this demonstration, everything I've been doing has been dealing with DNS. But the kind of the important thing to think about on this is that it's not limited to DNS. This is essentially something that can be done with any protocol out there. In this case, I use DNS because it's one of the most common protocols out there, and it's pretty much going to give you access to any system in the network because everything does use DNS and uses it all the time. But you could do this over essentially anything with that Slack space method. And I'm really curious why I actually haven't seen more dealing with that. This does have the downside over other DNS tunnels that it's not going to persist through several layers of DNS servers. It's either going to be point-to-point or it's going to make it through routers and everything that's dealing at the UDP or TCP layer or anything like that. But once you have things interpreting it at the actual application layer, then that tunnel that storage channel may disappear. So that is a downside to it. But it is still a very effective method, especially when you're able to, in most cases, set your own DNS servers and tell it where you actually want it to point to. So it's really pretty powerful in that aspect. And that's really about all I have. So I'm open to any questions you have, and thanks for listening to the talk. Yeah. Say that again? Then it'll just simply backlog it and store it in that linked list until it actually does see the traffic. Yeah. You can either give it a PCAP file and it'll strip out all the domains for you, or you can just give it a file of domains that are going through the network. Yeah. Yeah. For which application here? For which architecture are you talking about? Yeah.